So in this case, we are going to move on looking into the area bounded by the graphs. And the quadratic graph, the one that we have been working with, sometimes you have a certain region where they want you to determine or to calculate the area. So that is why I'm indicating here as the area bounded by the what? Bounded by the graphs. It's a region formed, right? The region that is what? Formed. From that region, there are ways that you can use by counting squares to calculate that area, or you can use the trapezium method, all right, which in this case I'm going to ignore and work with counting of squares by counting squares. Counting squares gives us a better approximate. It's actually an estimated area, not the exact area. You cannot have exact area. So it gives us approximate values. So it's a better approximate for our syllabus, right? Yes, you can use the trapezium method, but the best so that our answers will be in within the interval. We're going to apply or use what? By counting squares. So to obtain the area, you must have a region which is bounded by the graphs or the information that you're given. Let's say this is the region where the area is to be calculated. You calculate all boxes here. How many small boxes, those square boxes, how many are they in within that region? So the area will be given from those number of boxes that you calculated. So it will be number of boxes, small boxes over 100 times the area of a unit square times area of what? A unit square. Just like that. Count the number of boxes. How many small boxes do we have in that? Over 100 times what? Area of a unit square done. So the unit square is from the scale that we are given 2 centimeters to represent what? That is, we are going to take our unit scale for 2 centimeters. So if you are given 2 centimeters to represent 1 unit on the x-axis and 2 centimeters to represent 2 units on the y-axis, that's our unit square. Our unit square from these values that we are given from the scale that you are working from, it follows that its area is simply going to be 1 times 2. You multiply like a rectangle. So that's 1 times 2, which is what? 2 square units. 2 square units, or you can write 2 square units like this, or 2 unit square. Is the area of the unit square. The area of the unit square here from the scale. So if it was a 2 by 2, you multiply 2 times 2. If this side is 1 centimeter, 2 centimeters to 1 unit, 2 centimeters to 5 units, you multiply 5 times 1. What you are given on scale is what you multiply 2 centimeters to represent what, how many units on the x, 2 centimeters, how many units on the y-axis. That is what the unit square area. You multiply that, as you're done. So you must know the region. With that region, you are done. You must know the region that you are working with. For an example, I'm going to use this graph that we have been working with before. I want us to calculate the area using this graph. I want us to calculate the area. All right, calculate the area bounded by the curve, the y-axis, and the positive x-axis. Let's say this was our question. So the region first that is bounded, which region are you talking about? By the curve. This is our curve, the graph that we have drawn, the curve. All right. So you need a region which is covered by the curve. Okay. The y-axis, this is our y-axis. You need the region that will be covered in with it, bounded by this. The y-axis is this one. The positive x-axis, the positive x-axis from what? Origin going to the what? Going to the right. Like this. This is our positive x-axis. Which region, guys, is left bounded, covered by these? The curve, the y-axis, the x-axis, positive x-axis. Which region is left bounded, covered by those equations? This is the region that is what? Covered here in between. This is the region that they want you to focus on, covered here. So you calculate the number of boxes in that region. You calculate the number of boxes in this region that is covered, bounded by what you're given. So you're going to calculate, as you can see, guys, the whole rectangle, this one, the bigger square, I mean, this bigger square, it is, or it has 100 boxes. Every whole uh, box is 100 squares. So you're going to calculate, guys, all these. So the half, you can take another half to another half. It gives you a one, another half to another half. So you count everything in within. That was going to give us 446 boxes. So remember area, number of boxes for, okay, here. So we have got 446 boxes over what? 100 times the area now of the unit square, which is say the unit square, this is 1 unit, and this is 2 units, this one, the first one, according to our scale. So that's 1 times what? 1 times 2. You multiply that, so that's 2 square units, just like that. So we put the area. So that was it. This was going to divide by 100, 4,46 times 2, which is 8,92 square units. All right, so that's square units. So that is our area, just like that. So you use the area of the square unit. This is our square unit, the first box from the origin, the first box, this one, the first one. You calculate its area. What is here times what is on the other hand? 1 times 2 is you consider length times width, or according to scale, what you are given here on the scale, you simply use that is the area of the square unit. This one, 2 centimeters to represent 1 unit, 2 centimeters to represent 2 units. So you multiply 1 times 2, 1 times 2. That is 2 square units. You have the area of the unity square. So that's basically for area. We are going to add more questions later on, but for now, that is what you can actually use for revision. All right, for revision purposes, so that when you add more, you have understanding of what exactly we are dealing with. All right, so that is it, guys, till we meet again.